Hi everyone, Rodrigo again. I just give another talk about Zbus. I'm Zbus author and maintainer. Uh, at, at this talk here, I am going to talk about the survey we are running. I'm going to let that open. Someone answered yesterday, for example, but that's good. If you want to answer that or share with someone that wants to answer, I'm going to let that open always, right? Uh, the survey started at June 7th, and I collect data. I consider the data up to August 22, right? Just some days prior to that. And we had 55 answers. For a survey, in the usual days, nowadays, it's good. It's not so few and not so much, but it can gives us some idea of what what you're facing here, right? The idea was to know who is using Zbus, how many countries are using that, if there are some places to improve or places to be happy, right? Because we are already in the place. I needed to do some treatment on the data. At the repository that is here, you can see on that QR code you can see the actual responses, the answers, right, on the survey. You can take a look at that, and on that link here in the that repo here is the Python code I use it to collect and do the data separations and analysis, and the actual treated file, right, with the answers. Because sometimes I need to normalize, because, for example, Brazil, someone answered with Brazil with S and another with Z, and I needed to change that, and this kind of thing, simple things. And I need to remove some commas and things like that, just to process that better. Okay, so the survey results were something like this. For example, the majority of them consider or act as embedded software engineer, right? And part of it, female developer. It's a thing that it's been changing along the time. I don't know if you noticed that, but in the past we talked a lot of firmware developer of firmware development, but now we are talking about embedded software, and it's a little different, firmware software, embedded software, right? But it's a thing that's being changed along the time. And there are other specialties here, but the majority of them are embedded system engineer. All the countries that we receive answers. So we have all the continents, at least one person at that country. For example, India, China. In India, we had 2 questions or 2 answers, and China just 1, for example. But we are touching that, so I paint. Just to have an idea. So we have Australia, New Zealand, and other countries. Okay, Europe, we have a lot of countries here using, and South America, just Brazil. I don't know. I believe that there are other people using, but they are not answering. But that is a big picture what is happening with Zbus and Zephyr at all, right? Because if they are using Zbus, they are using. Oh, do you want to take a picture? So the presentation is available on the SCAD, right? If you want to download that, you're going to have access to the links and things there, if you prefer. Well, I did some demographic things there, just to know who is answering, right? This is a basic thing. If you take a look here, the majority of the people that answer here has from 1 to more than 5 years, for example. So almost all of them are experienced on Zephyr, so which is good, right? We have a niche. We have a few people using Zephyr. We have few people using Zbus, but experienced people answered here, which is valuable for the results. Uh, we have a lot of types of things, but I would say that Zephyr is being used a lot for IoT and consumer electronics. Based on the answers here, the proof of concept was a research and proof of concept was a surprise to me, but it's interesting because we have a lot of portability on Zephyr, and that gives us the ability to test different kind of things and try do things and do the proof of concepts. And you can see home appliance as just one vote, one answer, and automotive and network equipments with few of them. Okay, so that's mainly, as we can see here, when we talk about IoT, we are talking about as well network and security and other things. Okay. Interestingly, it's I don't know. Almost everyone use ARM, and just 6 extensa. I suppose I know, but no RISC-V, no ARC, no other architectures. Interestingly, I don't know why, but they are missing here. I put all the options there, right, on the selection, just to be clear. Another thing interesting here is that 3 people that are not using Zbus answered the survey. I don't know, that makes me think that people want to talk about Zephyr, and they are trying to do something, and they use Zbus here to do, and they were talking about Zephyr, in fact, during the improvement points and things like this. But the majority of them is using as expected, but a lot of them is considering or just studying or just kidding with that, right? This is one of the things. Industry is the majority of the use cases of Zbus. Hobby a lot, and a few, and academic fewer, right? I'm doing that for academic as well. And just to see, Zbus was added to Zephyr in Zephyr 3.3. So just 2 people were starting to use that as at the very beginning, right? The rest of the 3.5, 3, and then 3.4 we have 10, which is interesting. I don't know why. Maybe it was, I need to check with Benjamin, but maybe it was based on the talk, the Zbus talk. I'm not sure, but maybe that could be the event that make that rise. I need to double check that, but we can see 3.7 was the most usual or starting point. I don't know. So here we can see that one-to-many was the winner here, right? So that's one of the things that we because if you see here, many-to-many is not so common, but one-to-many is pretty common, and we can see that in in a lot of systems. So it's pretty common, and we can see that intermodule communication. It's almost when we are talking about independent modules or independent software entities talking each other through a mechanism. So it's being used for separating code, right? And IPC between threads, it's one of them. Zbus, in fact, is not a kernel object. So we are not talking about message queues or FIFOs or thing like that. We use those kind of things inside Zbus, but we can, we can consider Zbus as a IPC between threads. I don't know. Yes, an abstraction at least we can do, right? So we have different kind of things here. I'm happy to see this kind of thing. We have some some balancing in the types of use. So people use more message subscribers, other listeners, other subscribers. That's good, because if we have some of them that's not used, so we would have something that was not well designed in my point of view. So that is the picture that all the things that we have there are useful, at least in my point of view. The thing that it's interesting here is we had a lot of benefits listed there, and modularity, flexibility, and reuse of code was one of the I don't know, it's the majority here, and we have one-to-many and many-to-many communication. So the primary goal of Zbus was exactly that: modularity, flexibility, and code reuse of code. So we are keeping going and doing and delivering that, and I wish to continue doing this kind of thing. So no dependency injection was one of the other things. Okay, and the coupling, which is similar to modularity, was not considered. And here I had some at that time I had some features in mind, and I asked how important was that for the people, right? 1 is less important, and 5 top. And we see that we have some kind of distribution here, but the people want to see that. So mainly if you are trying to use, or you are using some modern SoC, which usually has the core MCU, you have a radio MCU, you have a peripheral MCU, you have some kind of things like this, multi-core is pretty important for that kind of scenario. But we have from 3 to 5, we have a lot of people. And the multi-target is that thing when you are make 2 SoCs talk each other. It's similar, and we have similar responses as well. That is one of the things that brought me some attentions, is how important is to integrate Zbus to the other systems, Bluetooth network, input, I don't know, RTIO, and a more expressive amount of people said 5 or at least 4, and that's interesting. And I invite you, the community, if you want to do part of it, we can work together to make that for different kind of systems, and we can integrate and make that optional, of course. But that would be great to have Bluetooth or Wi-Fi or other features integrated with Zbus, and you just need to use a single place to talk, right? It's a channel-based communication that would help a lot. And I'm going to talk about that, about one comment on top of it, just in a few minutes. What the new features or capability would like to see, and this one is interesting as well. I am using protobuffers. I personally, so in my internal development, I am using protobuffers, but Zbus does not support that yet. It's not in place or ready to work already, but you can do that. And some of the suggestions during the survey was about doing this generating channels or something based on protobuffers. Just a note here. At first, at the very beginning, with Zbus, the first implementation of that, we generate all the channel code. All the channel code was generated based on a file or config file or something. But after several discussions, we decided to do that in code using macros as Zephyr does. And we changed that. But this seems to be a kind of request to get back to the origins, and maybe it's a possibility trace and debug for Zbus is what we are trying to do with ZView and some other initiatives to trying to get statistics or trying to see what's happening to Zbus. If you enable logging, Zbus log, you already you are going to see a lot of feedback, and I suggest you, when you are trying to use Zbus for development, enable asserts. A lot of things that we are implemented there use asserts to give you instant feedback. If you are using something wrong in a wrong way, or if you need to increase some pull, or if you need to do something, the assertion will raise and tell you. So I suggest you, once you start to use Zbus, enable asserts and take a look at that. After that, if you are going to, I don't know, send that to production, you can just remove the assertions and keep going without changing anything. Okay. And we can see here some host API C, C++, Python welcome. That is an indication of that Zbus Linux version, or something like this. Someone wants to use a C++ or Python to talk to Zbus. It's something that we can. This is just one vote because it was an open suggestion, not on the list. The top one were just on the list. Okay. Based on the Zbus capabilities, how that can contribute to the development process. So the majority is at least 3, so it's good. But the top one is the 5, which is good. How easy this is. So happily no ones here, just 2, 3, and but the tools here makes me think what should be the part of is making their life harder. I have some answers on the survey as well about that, but they are open. So if you want to see the complete answers individually, you can take a look at the data. But so it seems to be easy. 42 people answered, which is easy to use, which is good. The documentation, we have more balanced thing here, but the 3 from 3 to 5 of the majority, no ones here, that's good. But 2, we have 5 people said that's 2. So maybe we need to improve some parts of the documentation, or maybe the documentation is too big. Someone told me it's too big. It's not good because it's too big. So, and sometimes that happens, and I don't know. We can discuss more that on the future of Zbus to improve that. But I think that documentation is a work in progress for Zephyr at all. So we are working on that and improving that to make that more clear. And I did a lot of effort to make that clear, but we can improve. And I just asked just to see what people are using other than the mesh subscriber and the observer types. And mesh subscribers is massive here, so a lot of people use that. And what message subscribers and channel ID, a lot of people is using that, which is good. Iterate over channels and observers, which is interesting as well. Client frame, a lot of things. But the thing that makes me think about, or I don't know, I'm a little worried about, is the priority boost. If we don't enable that, we are going to have priority inversions on the message subscribers. I say that explicitly on the documentation. So if you are using message subscriber, so we are the majority of people is using message subscriber, but is not using HLP. If you're not using HLP and message subscriber, you are facing priority inversions all the time. Maybe it doesn't affect your code, okay, but the thing here is the only thing that you need to do is attach the message subscriber to a thread. That's the only thing that the HLP needs to calculate or makes the priority elevation. I don't know if you know, but the HLP protocol elevates the priority of the publishing thread based on the observers of the channel, not the threads that are involved in the communication. It's not like a mutex, for example. If you have 3 threads trying to access the same mutex, the one that has the mutex will inherit the priority of the highest, which is waiting for that. So you have a priority inheritance, and then you can keep going. But in the Zbus case, we could not consider that priority inheritance because the observer is not engaging. It's not engaged on the communication. It's waiting the notification, so the name of it will not appear in the mutex because it's not trying to read the mutex because it didn't receive the message yet, right? So the HLP was a improvement, a feature that we added there to avoid priority inversions on message subscribers. So I suggest you, if you guys are using message subscribers, take a look at the HLP protocol to avoid priority inversions, because of the priority inversions, you are going to have you are going to see more latency on the publication process. Because during the publication, you are going to have you are going to be preempted during the publication. So that is the negative side of using. If you are using all the threads with the same priority, that would not be a problem. But if you have different kind of level of priorities there, you need to use HLP. Right now we are using as a lock mechanism on Zbus. We are using semaphores, right? So semaphores are really light, but they don't have this kind of elevation. So we implemented that separated, and you can see that working pretty well when you attach message subscribers to threads. So that's the only thing that you need to do. The latest quantitative questions I asked there was if you are selling something with Zbus, which to me is important, right? I don't know if you have the same, because if you are selling something, you are doing serious work, or you are doing that to do in the shorter time to have the most returns and things like this. It's pretty interesting. So, oh no, there is another. This one I need to interpret to see. This one was about how Zbus was changing people's mind about software architecture, and a lot of answers there were positive, and they are changing people's mind. So they, oh my God, event-driven or separated or modular. That there are a lot of different answers, positive answers, and we had 4 neutral ones and 3 negatives, right? And which is pretty good. So one of the things that we want to have in the past was that idea of architecture improvements and things like this. So that's happening. So sorry, I said that it was the latest, but it's not. Here I asked if they are considering alternatives to Zbus, and the majority said no, and the others said they are implement themselves because Zbus is not good enough for their scenarios. That's amazing. And other are using Nordic Application Event Manager. It was Nordic is changing to Zbus. A lot of samples and things they are doing internally, they are doing on Zbus. But there was that before, and that is for just NCS, not for the vanilla Zephyr. And we have message queues as options, which is pretty okay. DDS and ROS2 options, and quantum frameworks, which is a pretty interesting approach as well. But it's not just a Zbus alternative, it's a Zephyr alternative, right? And when you talk about that answer, sorry, that should be there. We have a cloud word here, a word cloud here, and we see Zbus, architecture, yes, and other positive words. Some of them are not positive, but interesting. Okay, and I'm going to speak about some of comments here, and I'm going to do the Q&A. I received a lot of supporting messages. I'm really thankful about that. Thank you very much. That's I don't know. That's a feedback that's amazing for me as an independent developer. I'm not working on a company pay me to do that. So that kind of feedback is amazing, right? I'm not asking you to thank you all the time. No, it's the proper time to say that, and I was pretty happy to see this. And more short and simple example, that is one of the things we can definitely improve. We saw a lot of samples, complex samples on Zbus, because we have a lot of possibilities, a lot of things to do, and we have complex samples. So maybe the hello world is a big one with a lot of things to see. That is clear that you can do a lot of things, but it's hard to understand. And the learn curve for Zbus is steep. I can see that. But I can say after when you start using that, it's hard to stop using that. I would say like this. And this comment here was one of the things that make me think. He or she, I don't know, is saying here that if you use something that's different from queues, FIFO, mailbox, mutex, or something, you're going to lose compatibility. So you should go away from Zephyr because of it, which is weird, right? If we innovate, if we do things that others don't do, we are going to lose something, but we are going to win a lot of things. But that makes me think a lot about it. But I don't know. It's pretty hard to do. And maybe other communities can get the Zbus idea and implement that. For example, FreeRTOS or Nutix or other. I was invited to port Zbus to Nutix, but it was I cannot maintain two versions of Zbus in different RTOSes. No, I cannot. That's one of the things that I would like to share with you. Some people that is all the time it happens. Part of the people wants to have all the features statically located on the device, but as a API provider, a subsystem provider, I would like to offer the community the best way to work on that, the easiest way. If we do that statically, you need to do a lot of extra effort. In my point of view, when we do that dynamically, in a dynamic way, you are going to use heap, but it's easier. It's easier. So in my development process, I usually do everything in heap at the first moment, and I'm going to, when I optimize, I'm going to remove from the heap and put static. Remove from the heap and put static. And I'm going to remove the dependence to the dynamic. But at first, to be fast, I usually do that in dynamic allocation. So that is one of the things. It's my point of view. I don't know if someone share with me that kind of thing, but it's easier to have an API that you just call something and that happens. Other than you need to declare 3 things and then use those things that you don't understand why they are there just to be static. So we are trying to do the best to make static allocation available, but the dynamic allocation is easier from the user perspective. And we are trying to keep that just as the beginning. And as soon as you are getting more used to Zbus, you are going to optimize your code and remove things from the heap. Okay. If you want that one is one of the things that I would like to make clear. If we want to make a light version of Dbus for Zephyr, I stop here. We are not doing a light version of Dbus. We are doing a Zbus, which is different. Just the bus is equal, right? No, but the Z is different. We developed the bus thinking in embedded systems with high constraint, several limitations, and things like this, right? So the thing that he commented, or she, out here, it's possible with Zbus, but just remembering, we are not getting something from Linux and put on Zephyr, I don't know, cutting some things and put there. No, we did everything from scratch, and that was the result of the work, okay? Once you want to use the static allocation, there are some, we are talking about challenges here, right? Memory management with the static allocation is one of the problems they have. So some of them are asking to have static allocation, right? And other are saying that static allocation management of memory is hard to do. So what should I do, right? What can I do here? I usually do what I think is the best for the user. The user will try to start using. If you have a lot of trouble to start using something, I don't know, the possibility of you to give up on that is high, right? So it's better to be easy at the first. When you get used to it, you can improve and you can do that better and more. But that's one of the things, right? So memory slabs, tricky. You need to know how many nodes you need to have. It's pretty hard to have this kind of thing. And in short, here we have some kind of problems with C++ because of macro compatibility and some compiler compatibility in terms of other things. So since the beginning, I was trying to do everything for C using the Zephyr Wave macro, but we still have some C++ challenges. If someone that uses a lot C++ wants to help me on that, I can work together with you guys. I don't know if you prefer to try to solve this kind of thing. So we have some solutions in mind, but I'm not so used anymore. I worked with C++ in the past, but not for a while. One of the challenges they have is to choose subscribers, listeners, master subscribers, and now we are going to have iSeek listeners, right? So we have a lot of kind of things, type of observers, and you need to understand each of them to know where to put them and how to get the best of each. And that's usual when you have some abstraction and you have a flexible thing, right? I cannot do some flexible, general, and thing like this if we don't have a lot of aspects on it, a lot of configurations, a lot of things to change, okay? The listener, in fact, one of the big advantages of Zbus is the VDD. I don't know if you are aware of it. This is a virtual distributed event dispatcher. In fact, we don't have a dispatcher. We don't have an entity that dispatches the messages. The publisher will dispatch the message. So one of the things that we have here, when you publish to a channel, you run the listeners. So the publishing thread is responsible to run the listeners. It is under the hood. You don't see that, but it is. That is why Zbus is fast in that approach. When you try to run listeners, you just call a callback inside the function you are running. So you don't need to even change or switch context to run the listeners. You run all the listeners, during the process. So you publish, you run the listeners. That's fast. That's what we were trying to achieve when we developed the listeners. So it's pretty hard because you need to know that the listeners are going to use the stack of the publisher. So the publisher needs to have stack enough to call that publisher, the listener. So this is the kind of thing that you need to know, and you need to get used to it, use more Zbus to understand better. But that is one of the things that we needed to do to achieve the fast and less context switch on the execution. Okay. When we are run out of RAM, we have problems with everything, right? Zbus is one of the things, and sadly, it's pretty hard to do to deal with this kind of issue. Low memory is a nightmare, right? When we are talking about stack memory, we have stack sentinels, we have stack need stacks to see that happening, but it's pretty hard to deal. In that way, the only thing that I would say to you is with the tooling, when we are going to be able to see the Zbus working, maybe that could be easier because you see the changes and things happening there, and that would be easier. But for now, just use the asserts to receive some feedback, some insights about it. This is the same thing. Oh, okay. So I would like to open up for you guys to the Q&A. I'll be here if you need some questions. He's there.
Thank you.
Thank you.
Yeah, so on the previous presentation, before lunch, one of the things on the roadmap you mentioned was about having agent proxies.
Yes.
So there could be like a multi-processor communication, so then Zbus would be like an abstraction.
Yes.
Is the idea that will be abstract enough that you could run the communication via UART or CAN?
Yes.
Or
yes.
any media?
Yes.
And what is the progress on that at the moment? Is there already a discussion in the community?
We are implementing that already. We are in the first stage of implementation. We have a sample working with a blink LED, but it's on the way. And we are already we have the RP message working between cores, and we have a UART example between SoCs.
Okay.
Okay. On the other presentation, you can see the link.
Okay.
If you download that, you can see the link of the repository we are talking about.
Okay, perfect.
Okay. Any other questions? No.
Going back to one of those points about the message buffer sizing is hard. I forget the exact wording.
This one here?
Yes. I'm just curious on what your view is on, sizing memory slabs is tricky. Is that any easier than properly sizing the heap? why are they different? There's still magic numbers you need to figure out.
No. It's harder. It's hard. It's also hard to decide the size. It's almost the same thing. In fact, I'm just I just put the comment here. You see, but I don't know. Once you have that at first, and as you are noob or a beginner on Zbus, that would be another thing to think, and I would avoid that at first. After that, you can use a members lab or something. You decide the size of things. You see, that's the only benefit I see. If you are using members labs or a syship, you are going to see the same issue in the same. I don't know in the same time, but you're going to see face the same issues. Okay.
Going back to the slide about what Zbus feature is used, so the message subscriber come first, I think,
Okay.
and then the high priority locker come at the end. So what's your take on that? So first of all, I'm kind of not surprised. So of course it's a bit scary, but I'm kind of not surprised about this statistic. And so what is your take on that?
I believe that I need to be more clear on the documentation about that. And I don't know if people are concerned about priority inversions. In fact, as IoT applications, and we are not talking about critical path or something like this, people are not talking about prioritizing tasks, or maybe all the tasks have the same priority, and we are not worried about it. So
one of my observation is that I think, and this is related to the one of the question or comment was, oh, I have subscriber, I have message subscriber, and I have a listener, and which one should I use?
yes.
Guess what? Message subscriber is quite easy to understand, and in other RTOS or in other operating system, we have kind of message queue, message passing, and that's of course the one you will grab because that's the one you understand. Maybe not the one that is appropriate for your system, and then come with the next. If you are not careful about the aware about what happened if you do that with a priority inversion, you may not think about to just attach the thread. So yeah, so that's one of my observation, and I wanted to get your feedback on that. So thank you.
Okay. Thank you very much.